Hi, this is Dave. In this video I'm going to show you how I modified my Electroware C64 2-in-1 power supply unit for heavy duty use. What I found initially with the power supply is that it's not quite up to the task that I put to it, which is to power my Commodore 64 and my original 1541 floppy drive. So what I've done is I've modified it to have a 30 watt total capacity on DC, and it's on right now, and you can see it provides both 12 volt DC for the floppy drive and 5 volt DC for the floppy drive and the Commodore 64 combined. So all told, we have an Electroware 2-in-1 PSU with about 50% more capacity than it had originally, which was 20 watts on DC. So what I'm going to do in this video is go through a lot of things. First, I'm going to tear apart the Electroware Dual PSU and show you some of its characteristics. I'm going to tear apart the Mean Well IRM-30-5 switching power supply, and I'm going to show you how I did the impossible, or what seemed impossible, and managed to install this power supply inside this small case. So we're going to go to the bench. I'm going to set up a bunch of chapters because there's lots of steps to this process. And if you're not interested in all that, just come back at the end and I'll summarize what I think are the hits and misses of doing this mod. So here we have the Electroware. I've already opened it up, and actually let's bring the Keelog back in once just so you can see them side by side. So this is the 2-in-1 PSU. This is one called a Dual PSU from Keelog. The 2-in-1 PSU from Electroware, and they're meant to do the same thing. They're both meant to power a 64 and a 1541 simultaneously. The Electroware also uses the Mean Well IRM-30. The Keelog uses that one. The Mean Well has this transformer. The Keelog has this transformer. This transformer's characteristics, based on my measurements, are it provides around 10 volts on the Commodore 64 side, which is better than the 11 volts that one was providing. So I'm going to go with the Electroware for my project. Now, because I've already done the experiment that I replaced the 20 watt with the 30 watt, and that satisfied my power requirements to power both an original 1541 and the 64, I have every reason to believe that that's going to work as well with the board and the components in the Electroware. So set this aside again. In Electroware, construction's a little bit different. It's not glued together. There's 4 screws that open the case first. There's another set of screws that hold the PCB in the base of the case. It has connectors instead of just things soldered between the top and the bottom of the case, which makes it convenient, at least for this project here. It has a couple curious things. It's got some LEDs mounted high up off the PCB, and that's so that you can see them through the vent holes right there. And so I could do something like what I was doing with the Keelog, which would be take the IRM-30, mount it right on top. The design-wise, what I'm thinking is what will be the most rugged, basically. If you drop the thing, is it going to break? I happened to buy the screw terminal one just because I thought it would be convenient for doing some testing. But now I'm like, well, geez, how can we sandwich this in here? But remember, we're going to take out the 20 and replace it with wires that come up to this one. So is it possible to get this thing inside the case? And at first glance, you'd be like, no way, it's not going to fit, right? So a cool thing about this Mean Well power supply, the screw terminal version, is that you can just pop the case open. It has little tabs to take off the bottom. And then once I opened it up, I said, oh, well, look, this looks a lot like the way that a non-screw terminal version of a Mean Well power supply looks. Here's another one of the 20 watt versions. You've just got 2 pins for the AC and 2 pins for the DC. Well, here they are in a similar orientation, 2 pins here and 2 pins here, soldered to a little PCB, and that PCB is just there to hold the screw terminals. So I just got finished desoldering those pins, which means we can pop that PCB off the power supply like this. Okay, so now we're looking at
the IRM-30 inside a screw terminal housing. So what's going on here? Well, it looks like it's kind of potted in there or something. So I was like, well, is it going to be possible to take that thing out? And you know, if we lost this case, look at how close this is to fitting in the Electroware case. I can almost get it in there, but for that plastic case on the outside. So just a little bit of prying the board up shows that it comes out pretty easily. So it's potted in there with this kind of soft, rubbery gray goop, but it looks fairly safe. I mean, it's covered in this stuff. If I be careful about the way that I mount it, what if I just did something like fit it inside this case? It just happens to fit almost exactly. And because it's so wide, its pins will straddle. They'll straddle the printed circuit board in the Electroware power supply. They'll just drop down in this little space, you know, that's there. So that was the first thing. It will fit in there. Will fit in there. Now the question is, will it fit will it fit in the bottom part here? I said I think side to side it'll fit, and it looks like it won't quite fit because what seemed clever before, they got this transformer mounted in. It's slightly an angle, and even you can see that there's markings on the PCB that it is designed to be that way. So if I can just get this in here, sure enough, of course I can take the LEDs out and, you know, run those connectors underneath or something. So that's no problem. And because Electroware has connectors, it's actually the connector that's gonna, if I remove that, I think there's enough space between this transformer, which is in a safe plastic housing, coming against this side here. Take those out, and you see there's just enough room. And if we replace this connector or move it over a little bit, possibly, if I'm interested, I might solder those pins. I don't know. We'll see what you can do with the connector, but I think I can get this Mean Well 30-watt power supply inside the box from the Electroware, 2-in-1 PSU. That'll be super cool. You know, it'll look normal, and I'll have something that has a lot more power, 30 watts for DC instead of just 20, and will work for me. So let's get to it and do that. Disconnected this connector here. That allows me to remove the PCB and flip it over and see what this looks like on the other side. So here's the boost converter that takes the 5-volt output from the Mean Well power supply and provides the 12-volt DC that's needed by the 1541 and other Commodore drives. They've put a piece of electrical tape over the AC, so anywhere there's high voltage in here, they seem to have been pretty careful with their design. So all I need to do, just like in the Keelog, I can desolder the Mean Well power supply right there, and there, and then the DC connections right there and there. So All right, so now that we have the IRM-20-5 removed, and I said, it looks like this will just about fit. Cut off the plastic pieces that lock it on there. But again, who cares if it's locked on there because it's going to stay on by friction. So let's do that. There we go. So that's smooth. Like I said, I'm going to just have to desolder that one because it's just in the way. All right, well, I got that connector off, but it was a hell of a hard thing to do on the ace or on the ground. So let's take a look at what we've done up to this point. So we removed the IRM-25. I removed the pins for these 4 wires, which go to the Commodore 64 cable and connector, and then of course removed the plug that goes onto them, and that is to make room for the IRM-30 removed from the screw terminal case and board. So what I found, the IRM-30-5 is going to fit right in here, and it's going to overhang this board a little bit, and its 4 leads are going to drop down on the sides, and that's where we're going to make the connections to where they need to be on the underside of this. So so how does it fit in there? Well, it doesn't quite want to fit in there, but if you push it, it will fit inside the Electroware case. And what we want to be sure is you can see it through the cooling grates or slots right there. Nothing electronic or electrical is exposed there, so that looks good. And you can see it's all the way up against these posts that are used to put self-tapping screws in that connect the top to the bottom of the case. And the other thing I did with the connectors is, besides removing that one, these ones I made them thinner. I took off the locking mechanism and I marked them so they're keyed, so we know which way they go. And the reason why I took off the locking mechanism is, on this one, the locking mechanism got in the way of the IRM-30-5 because it's wider than the Mean Well IRM-25 that was there before. And I took it off over here. I took there was a key on the outside here, and what that allows us to do is move the PCB ever so slightly this direction, and that's helpful to get things to fit in correctly. There's some play allowed that will still let us put the case back together. Okay, so new power supply from Mean Well's in here. Let's put this together. This connector goes, the AC connector goes on there. The connector to the for the output from the Mean Well goes here. I'm sorry, not the output to the Mean Well. It's the connector to the 4-pin DIN that goes to the 1541-2 DC power plug. All right, so those two are connected, and now we're going to sandwich this together as if we're going to put the screws back in. See, you can see it's a tight fit, but there's a groove in the molded in the plastic there, and we've got it in. It's in there right now. You can hold it completely closed, and nothing's moving in there at all right now. Originally, the way it comes from the factory, or comes from the manufacturer, is there was this piece of foam glued to the top of the transformer, and presumably that came in contact with the top of the case. So if we really want to make sure nothing can move around, we can put that back in there. But you can see it's a super tight fit. And the things we have to be sure about are that we certainly can't let anything on the exposed now bottom of the IRM-30-5 short to anything down here, right? So we're going to have to separate those electrically, insulate them from each other. I think what I'm going to do is I'm just going to kind of spiral wrap the IRM-35 with a layer of electrical tape, around this way, at least one layer. And what we'll have is the very edges will be exposed, but that's okay because those are just going to be over here past the sides of the PCB, and we're going to solder to those because that's how we're going to connect it where the IRM-25 used to be. So let's wrap it. There we are. So I've marked the Mean Well power supply saying it's the RM30-5 since we've removed the cover that had all the details, and I've marked the pins as DC minus and plus there, and AC live and neutral here. And then now I have some wires and some heat shrink tubing, and we'll use the black and the red for the DC plus and minus, and we'll use this wire for the AC live and neutral. And on each of those we'll put a piece of shrink tubing, so once it's soldered up we can slide it down over and cover up those through-hole terminals that the Mean Well has. And now I think we're ready to test this out. So what we need to do is connect this 3-pin connector here, which goes to the 4-pin DIN, which is the power supply here for the drive. And we need to connect the AC switch across the mains right there. And just get this arranged so we can see what we're doing. Okay, so let's power it up. Power's on. Turn on the switch. All right, well that's good. We see the LED on the DC boost converter that showing that that's got power. So let's check the voltages. Plus 5 volts right there. And then 5.08, 5.99, that looks good. Let's check the 12 volts coming out of the boost converter. That's over here. 12.43, 12.44, that looks good. Now let's check, even though we didn't mean to change anything about it, let's check the AC voltage that would be going to the Commodore 64 as its 9 volt supply. That's this brown wire and the gray wire right next to it. And we're seeing 10.7 volts AC, and that's without a load. So anyway, looks like we didn't do any harm by replacing the Mean Well power supply. So let's move on. One of the most major changes I made, of course, was that I decided to put the 30-watt Mean Well power supply inside here, right? So now it's inside. Now, of those things, probably the most questionable thing I did is I wrapped it completely in electrical tape because I had taken it out of the case. That, in hindsight, might not be the best idea in the world, right? If this gets hot, the components on the bottom, it might be too hot for that arrangement, and I'm going to have to insulate it from the PCB anyway. And then we can use some of my thermometer temperature measuring gear to test it under load with the 64 and the 1541 and make sure that's all working, and then make a decision about how we're going to package it up back in the case. All right, so we're ready to power this up and test it under load with the real 64 and 1541 DC, modified for DC input. We'll plug the power connector for the 64 in there. This is the 4-pin DIN from the 1541 DC, so that will go into the connector, the socket on the Electroware power supply. And now we're ready to plug in mains voltage. Mains plugged in, and we're going to power the Electroware up. All right, it's on. The monitor is on there. Let's power on the 64. All right, we've got a screen, and let's power on the 1541 DC. There we go. All right, so to test this under load, what I'm going to do is what I've done before is load the 1541 test demo software to test a floppy disk out. Check disk is loaded. And I'm going to use an old junk disk, but we're ready to run it. And meanwhile, while this is running, I'm going to be using this infrared thermometer to test the temperature. So it might have occurred to you that when I mentioned these status LEDs, they used to be visible through the grill grates, or the air vents rather, in the top of the case, because they were pointing that other direction, and that's where we have the IRM-35 right now. It might have occurred to you that if I mount them on, now here on the bottom of the case, that they're going to be pointing downward into the bottom of the case. That's absolutely true. I didn't think it was particularly useful to have them visible through the vents anyway. I don't mean to, I might as well install them because they're there, or the device had that feature. But what we can do, I think, is this case is going to go on, it's going to go on like this. Those two LEDs are going to be right under here. Well, why don't I just, drill two holes where they are in the bottom of the case, and maybe optionally fill it with some transparent or translucent epoxy, and then we'll be able to see if those LEDs are on just by looking at the bottom of it. I mean, I don't need to see LEDs all the time. It's just a diagnostic tool, and you rarely need to see that, that those lights are there. But anyway, so let's look at what are the last things we need to do to assemble this. So if we turn it back over, what we want is something to further insulate the IRM-30 from the PCB down here. And what I've decided to use, that I poked around and found pieces of packing material on this kind of foamy, thin gray stuff. And my thinking is, so the idea is, what we're going to do is just put it in here, fit it in there, affix it with some double-faced tape, and you see it's exactly the width of the PCB, so there's no way anything from the IRM-30-5 will be able to short against there if ever, something got scratched through those multiple layers of electrical tape. Alright, so through the magic of video editing, I got the holes drilled for the LEDs. Unfortunately, in the process of drilling the holes, I slipped a little bit with the drill, and they're not in line with each other. So when I came back, I tried to bend them so that they would be in the right positions, and I ended up breaking the green LED. So if you remember, there's also an LED on the 12 volt the DC-DC boost converter, and that's just annoying, having a status LED inside the device that you could never see. So what I decided to do is not, because I don't have a replacement LED there, I'm going to skip the 12 volt LED status over here, and I'm going to use the LED from the SDXMDZ as the status for the 12 volts, because that's the component that provides that. So what I did is I drilled another hole over where the LED is for the SDXMDZ. So this light over here will indicate the status of the 5 volts, and the 12 volts will be from there. Next, we need to bring in the rework station and shrink the heat shrink tubing. Okay, so now that the heat shrink is done, we're ready to assemble this with the screws. So what I did is I ran to the hardware store and got a set of screws that will reach the entire length from the top all the way through the bottom. Got some screw head covers, got some rubber thread protectors. So let's just fit this together without using the original parts and see what we can do there. So this goes together like this, and I'm thinking screw through here, out the bottom like that. So now the device will be like this, and it'll have these 4 legs. Well, these guys will ultimately go there like that. Well, that looks like it'll work pretty cool. So if we assemble the case this way, the couple things we have to do is make sure there's enough clearance for the PCB where each of those screws is, and then also we don't want the screws to be able to short to anything. So what I'm going to do is take these plastic disposable drinking straws and cut them to the length of the screw so that we can put those as sleeves over the screw. And then on the PCB itself, what's nice about this Electroware PCB is that those big holes are at the very edge of the PCB, and there are no traces, where the hole. There's no trace where the hole is. So I'm just going to take my cutters, I guess, and let's just get rid of those holes, right? We want there to be room at the corners for those screws. So we'll just snip off the corners of the PCB like that. So now I think we're ready to put the thing together. So so for these guys, those pieces are going to have to be about that long. All right, so let's put this together. All right, looks like we've achieved packaged 30-watt heavy-duty power supply. So put it in, power on, and here we can see we've got both the 12-volt LED light on the SD-XM-DZ, and we've got this other LED in here indicating that we have 5 volts.
So that's most of how I did it. I'm really happy with this project. I finally got it working the way that I wanted. Unbelievably, I was able to reuse the Electroware case. That's not necessary. You know, if you don't want to screw around with that tight fit, put it in, you know, a Commodore case, put it in some other case. But what I think we've done here, let's go through some of what I think the hits are here. Well, the first thing is the Electroware PSU has the right 9-volt AC voltage for the 64. So that's not negotiable. We have to have that. So we've got that with the Electroware. I think what we've done is possibly made the smallest heavy-duty PSU for the C64. You know, 30 watts total. If you're just using it for a 64, that's a ton of power. And we know that it can at least power the 64 and the original 1541 with its hungrier motor. Next thing, hits-wise, I like the aesthetics of it. My original Commodore power supply from the 80s looks like this, and it's basically mimicking that, but in a smaller format. As it happens, you know, I left these screws along so it's got these legs and it holds it up a little higher. Arguably, that could improve the airflow around it and help with cooling. As it is now, this gets about the temperature of the human body. It doesn't feel too warm to the touch. Just it's in the high 90 degrees on the outside of the case and perfectly comfortable. My original power supply used to get very warm, and in fact, back in the 80s, one of the things we used to do is put legs on the power supply to hold it up because it has vent holes on the bottom. So I've accidentally mimicked that, and so I like the aesthetics of it. And adding the silver screws, you know, I could have painted those or something, but Electroware already had silver components on it. It had a red switch, so I added red legs. It had silver, and I added silver. So I think it came out looking nice. There's a tiny bit of room in there if you want to add other things like a lamp that shows if the AC is on. If you wanted to fit a different size kind of fuse or fuse holder, you could do that. And then lastly, it can be returned to its original configuration. I didn't destroy anything in here. You could take the IRM-30-5 out, put the IRM-20 back in. You could take these screws out, go back to using the original mount holes. You'd have to, you know, futz around a little bit, but it's basically a non-destructive change, even though it's a bit extreme. Now, what are the misses? Well, there's no power on light, and like I said, you could fit an AC lamp, or you could just swap out this rocker switch for one that's illuminated. I don't need a light on all the time. I can, if you know, I know if the computer or the floppy drive's not working, I'm going to look at these diagnostic lights on the bottom and see what's going on. And then the other potential miss is that I know from my measurements that we are driving the DC to DC boost module in here at or near its limit with the original 1541, because that thing's labeled as 8 watts maximum, and we're pulling 2/3 of an amp on that drive, which is about 8 watts on 12 volts DC. So we're near the limit on the 12 volt power supply, but there's plenty of room to spare for the 5 volt for things like peripherals on your 64, exotic cartridges, or things that you have on the expansion port. So that's the project. Let me know what you think. Certainly let me know if you do it. If anything wasn't clear, and certainly some things aren't clear from the video that I made, feel free to ask and post a comment. But that's it for now.